Well, I'd like to welcome everybody here today for another community roundtable with the NERI SimCenter. My name is Greg Dearline at Stanford University, and I kind of coordinate the Earthquake Working Group and also co-chair of the, or co-director of the SimCenter. So today's topic, we're talking about regional earthquake simulations, and in particular thinking of kind of testbed simulations, and really to use these as a mechanism for advancing the development of data and models for these regional simulations. The big vision here, if we step back, like what's the SimCenter doing and what are we trying to achieve with the regional simulations, is really to focus on bringing in high resolution models into these simulations. So we want to be linking detailed local models of, say, ground deformation, structural response, and even aspects of demographics with regional simulations. And therefore, go beyond just, say, calculating aggregate losses or something for an earthquake or another natural hazard event, but really looking at local effects that could enable cities, such as you see here for San Francisco, that are developing different types of policies and planning and so forth, to be able to utilize this information for, if you will, engineering their cities. So that the tools the SimCenter is developing are kind of built on the performance-based framework. And those of you familiar with what Pierre did, Pacific Earthquake Engineering Center years ago, are familiar with this sort of framework. But this graphic shows how we're kind of building that out a little bit, thinking more explicitly of regional simulations and thinking uniquely about how we at the front end characterize the inventory of buildings, bridges, other infrastructure, also the population, the hazard, and carrying that through the performance-based assessment to damage and losses, but then also importantly looking at recovery and modeling things at that end more explicitly. So one of the key tools that the SimCenter is putting together is called R2D, which is basically a GIS-based platform. And as you can see in the graphic here on the left, it's envisioned that if you imagine those parts of the performance-based framework, from characterizing the hazard to the inventory, damage response, and recovery, you could think of these in a sense as different layers. So it's connecting all of these features, and it's also characterizing the uncertainty, beginning with the hazard through uncertainties in the inventory, carrying that all the way kind of through the simulations. Today we'll be talking about earthquakes, but the SimCenter has a broader mandate. So we've looking at, in particularly, hurricane, wind and storm surge, and also tsunami type risks. So characterizing being able to characterize multiple hazards, looking at different asset types, again, buildings, transportation, utility. And the SimCenter's developed some tools. One's called BRAILS++, which really facilitates the development of these inventories, which is a critical piece of the regional simulation. And then a key thing here is to mix and match multi-fidelity models. Could be a high resolution of one particular building or piece of infrastructure into a larger simulation that has lower fidelity for the features that are kind of lesser important for a specific study that's being done. So in terms of our discussion today, we'd like to really examine again how these regional simulations, in particular earthquake, can really drive the development and implementation of data and models, really advancing research and getting that into practice for these high resolution, high fidelity simulations. And so the goal in a testbed in particular is to really facilitate this collaboration and benchmarking, going from hazard into recovery type models. And we'd like, during today's discussion, and I'm going to introduce speakers in a minute that have some presentations to help prompt a number of questions we'll be looking at. But an underlying one is what makes a regional simulation testbed successful? It's more than just doing a regional simulation, but a testbed we envision as really a community-driven effort. And so some suggested answers to that might be is a successful testbed one that's broad and multidisciplinary, that brings in different stakeholders working on the testbed? Is it a simulation or a project that has longevity and persistence? That is, where people keep coming back to it, revisiting the data, improving on the models, and then looking for measurable advancements in simulation and data capabilities. These are not static simulations. The whole idea of a testbed becomes kind of a living sort of study. So some additional discussion issues and questions that I'd like you all to think about, and during the Q&A, you could kind of build on these or offer kind of opinions or thoughts. When you think about regional simulations, like who is the entity that facilitates transfer between what researchers are doing for a regional simulation and what stakeholders are interested in? Those of us who work in structural engineering or geotechnical, we're used to interacting with professional structural engineers or geotech to translate our research into practice. But when we think of these regional simulations, what's that middle layer of people who are working on that? So that's a question. When you do these high resolution models, it's a question, how much resolution is enough? That is, you don't want to apply high resolution when you don't need it, but you want sufficient resolution, and it's really tied to the questions or what decisions you're trying to inform with a certain set of simulations. Another thing is, how do we as a community, and in particular those of us in the SimCenter, promote open source, well-documented, community engaged efforts, that is, contributions of data and models to this endeavor. Oftentimes in these regional simulations, there might be certain data, could be data on demographics of individuals, could be sensitive utility infrastructure. So how do we manage and handle that data privacy and access? Are there ways to incorporate that private data into a simulation, say, without revealing it, just so that you could still it has an impact on the decision that's trying to be evaluated. And finally, the last one here is when we think about these local models, what kind of detailed information do we need to kind of inform these local models? Or if think of the ground motion world, we'll call them non-ergodic. That is, if you think of a damage fragility function for a building, it's going to vary city to city depending on what building codes were in effect at a certain time. For example, in Florida, the building code for wind has advanced. So the detailed information to simulate buildings there will be different than it would be in another city. So how do we collect this sort of information and manage it in a consistent way? Okay, so that's kind of an introduction. Just as Matt Schottler mentioned at the outset, we'll be using the Q&A feature on this kind of Zoom conference system. So rather not use the chat, but instead go onto the Q&A and kind of post your questions. Also, if you see a question there, people can upvote that. That could help us decide as a group which questions we want to spend our time on. You could also drop comments or engage in real-time discussion into chat. And you could also raise your hand if you'd like to kind of pose a question or comment verbally. But I'd like you to start out when you're listening to presentations, be jotting down your questions and then typing those into the Q&A, so we could stack those up such that when the speakers conclude, we could then get into some discussion. So finally, with that, I'd like to introduce, we have three speakers who are going to kind of prompt the discussion today. First, we have Elena Sutley from University of Kansas, who, as she'll describe, has co-authored a number of papers specifically looking at test beds. So she'll explain some of the lessons from that. Liam Witherspoon from the University of Auckland, who's worked with the Quake Core Group, a large research entity in New Zealand, and he'll describe a regional test bed. It's actually regional over the whole country of New Zealand. We're going to then pause at that point. We'll have those two presentations, and then we're going to pause for Q&A. And then finally, after that pause for Q&A, we'll come back, and Adam Zarnowski from the SimCenter will talk specifically about some of the efforts that we're doing in the test beds, and in particular, looking at the San Francisco Bay Area. Okay, so with that, I think I'm going to stop sharing and introduce Elena to give the first presentation.
Thanks. Are y'all seeing my screen okay?
Yeah, we could see it. Thanks.
Awesome. Okay, thanks everyone. I'm Elena Sudley, and it's such a pleasure to be here to talk about testbed experiences and lessons. Testbeds are an essential part of the development and testing of community resilience algorithms, or at least they have been in my research, and they serve the needs of training and educational purposes too. I've been able to incorporate these into my classroom as well, and I think it goes a long way. to really realizing and seeing community resilience in another light. So test beds can help enable multidisciplinary teams to design, test, integrate, verify, and validate resilience algorithms and numerical models at different scales and resolutions, which is critical for interdependencies. So what is a test bed? I want to just start with a definitional framework for us to kind of talk about. So I define a test bed as an environment with enough supporting architecture and metadata to be representative of one or more systems that the test bed can be used to design experiments, examine model or system integration, and test theories. This definition comes from a state-of-the-art review paper that my research group, specifically Amina Narami, Meredith Dumler, and I performed a few years ago that also surveyed authors who had published related to test beds. And at the time, test beds tended to be in the background of the papers and not highlighted necessarily as a novel contribution themselves. So it's been really cool to see just how much that has progressed just in 2 and 3 years. A year later, we also published a methodology for developing test beds. So I want to share today some of those findings and where that may lead us to think about what's next. So from the survey to testbed authors, we asked what were the minimum requirements for something to be considered a testbed. And looking at the results, we had 90 respondents. We did qualitative analysis of their comments. We identified 3 major categories across comments, and that was the applicability of the test bed to be applied to research questions, the requirements of what must be modeled, such as specific systems and hazards, and the accessibility and documentation of the test bed for the research community. So really important in building off what you just heard Greg talk about in a lot of ways. So here you can see on the screen some detailed responses where, the most people who identified something together said test beds have to be broadly applicable, but they also have to represent reality. In our evaluation of the literature, we identified 22 existing test beds at that time. And the table up here on the screen on the left, you can see the listing of the test beds, and then you can see about half, and I'll try to move my cursor, half or so were some synthetic. So, the Clark test bed, Centerville, Gotham City. So not necessarily representing real communities, but synthetic. And so then we marked, what kind of systems, what physical systems were represented in the test bed captured. And you can see we were able to break that down into several types of infrastructure systems. We ended up needing to merge anything social into one category and anything economic into one category, because these were much fewer and farther between where they existed. And then we marked which hazards had been analyzed for each test bed based on that literature review. If we take a closer look at the hazards here, you can see we found we plotted 3 different things: the number of test beds, the number of publications, and the number of survey respondents by hazards, and including earthquakes, hurricane-induced wind, hurricane-induced flood, tornado, tsunami, and this other category. And at the time, you can see the highest number of existing test beds captured earthquakes. They had models that could run earthquake simulations, for example, 11 at that point, and the highest number of publications, 41, that were using any of those 11 test beds for simulations. And you can see the fewest were tsunami at that time. But what's interesting is that wildfire didn't even make our list. You can see listed under other, there's one for urban fire, but just to say that it was very limited at that point, and no mentions of extreme heat or other chronic hazards that we're kind of increasingly seeing being looked at just these couple of years later. If we, since this is a roundtable on earthquakes, if we kind of highlight the test beds that existed on earthquakes, at least in 2023, and what systems they included, one thing I want to point out here is our search did not reveal much to any coverage on communication or wastewater systems. And the social and economic systems tended to be restricted for the most part to census data representation instead of really meaningful use. That has changed a fair amount in the past 2 years, and it's not a criticism, but it gives us this really nice opportunity and direction on what we need to do next. So you can see kind of what's covered synthetic, a mixture of synthetic and real communities. Most had buildings and water, and then, it kind of gets lighter as we move right across the screen. So with that opportunity and direction of what we might need to work on next, I created a list of some of the things drawing from the conclusions of the paper, and things I've continued to think about related to next steps in testbed development. It's kind of a long, detailed list, so it may be even too many items to be meaningful anymore. So I won't talk about each bulleted item in detail, but hopefully this can give enough to stimulate discussion later. And if I don't comment on a given bulleted item that you want to know what I meant by it, by all means, please drop something in the Q&A. So the first category of things that, next steps in testbed development that we need to see is this continual development of the testbed user interface. So I started with this one because like right off the bat, like Greg was showing some really amazing images, screen captures from the SimCenter that as a researcher, like I love to look at that. And that's exactly the type of thing that I want to be able to interact with when I'm working with a testbed. And so depending on the purpose or the intent of the test bed, then that kind of really needs to directly correlate to what that user interface looks like, and not just the user interface, but also the visualization of information. What data is being visualized? If I'm working with an emergency manager in a community, they probably want to see less of the probability and more things that they understand how to directly work with. And so even right there, that testbed user interface, really needing to get a handle on what testbeds are being used for and using that to drive all the things we model after that. And it can be a mixture, but in any case, a second category is data needs, data collections, and data security concerns. And, if you look at this list of things I've put on the screen, relatively speaking, we have decent building stock and transportation system data, for example, in the US. But the building stock data doesn't do a good job capturing our in situ condition, for example. So again, building off what Greg was saying at the beginning. So are there data sets that we can integrate that we're not using now, like inspection reports on maintenance and deterioration, so we can further progress that space on even just our building stock data? Jamie Pageant and colleagues published a paper last year about equity kind of in this space. And I really want to illuminate a point that was made from their work. And that is, we need to make sure that the data that we use doesn't have the least granularity, the least accuracy when it comes to representing the most vulnerable. I think about manufactured homes and how lousy the data is on where they're located, and really next to no information on the details related to manufactured homes and what directly relate to their hazard performance. Houseless populations, indigenous peoples are very poorly represented in census data. So if we're using census data as the primary data to model populations, we're going to overlook some that we really probably need to be thinking about first. When we look at transportation networks, making sure that the road quality, the stormwater drainage are represented in low income and older neighborhoods, or the type of pipe material, the size of the pipes and water distribution networks, so we understand the water quality that's being delivered to different users and households across a regional simulation. These are the types of details that make a really big difference in reality, but quickly become assumptions and models because that data is a lot harder to come by. And when that happens, it really erases the ability to understand the differential impacts in our models. So while there has been progress on all of the fronts kind of listed, there is still a dearth of knowledge and availability on long-term recovery. So our simulations tend to stop in the days after a catastrophe. And there's also really big, important research gaps that connect dots between mitigation and intervention strategies with post-event success, because when mitigation works, when intervention strategies work, A lot of times a disaster doesn't happen, so we don't go out into the field. There isn't a reconnaissance trip, right? But what that means, because it's not a very compelling data to go collect in a lot of ways, but what that means is that our ability to have confidence in validating interventions remains a challenge. And then lastly, for this list, I'll just touch on the need for methods for privacy and security. One of the things I've already mentioned a couple of times, we need human subjects data. We need financial data to really move a lot of our test beds forward. But we have to protect privacy. And this is true for physical systems data too. But we need methods, and I've seen some in the research already, but we need methods to de-identify data sets that still represent reality, to kind of reverse engineer data sets to truly anonymize and also make reusable. So those are some of the things I really hope to see more of and be able to incorporate into my work too. A third category is on testbed verification and validation. How does one confirm or show that the simulations we're doing are giving accurate and realistic answers? And that only is exacerbated, that question, when we're talking about long-term recovery. The longer temporal, nature of our analysis, the more complicated validation gets. So I think we need to establish validation metrics and to establish best practices to advise and guide on the type of data one can use to validate a regional simulation. We can do this well at the component level by comparing component fragility models to tests, for example. But at the regional level, it's a little bit more complicated. Hindcasts, ground truthing findings with local experts, and post-event comparisons to global metrics like direct losses, these have been used, and we need to continue fleshing this out. And most importantly, we need to establish guidance on whether the results of the simulation are reasonable or close enough to observations to affect actual decisions. So, for example, if a stakeholder's deciding whether to undertake some sort of mitigation measure, are the results of a simulation close enough to reality to lead to the same or a new conclusion? And then finally, when we ask experts on a survey a couple of years ago, what were the minimum requirements for a test bed, there was a lot of commentary on the documentation and reuse. So I do want to really emphasize this here, as well as highlight that the SimCenter and Core Design Safe has made just huge strides on this front, just, in the past few years, and maybe a little bit more than the past few years. But just how critical that really is. And we just need to continue even more. The fifth and sixth, so these final two categories, I'll kind of lump together, and maybe even under this consideration of best practices or even ethics. If we're modeling a real city, should we as researchers at least visit it once? Should we notify and develop partnerships with community representatives? As a researcher of resilience, it's so important to me to translate findings into practice, and test beds have so much potential to be powerful tools for communities. So I actually think this is critical from that ethical and best practices standpoint. It doesn't have to be exclusive. I mean, I think about the synthetic test bed of Centerville. The purpose, the intent behind developing that test bed was for that research team to learn how to work together and to test how their models would be chained and come together. So it was a synthetic city, and the purpose wasn't around modeling a real city or translating into practice. So this doesn't have to be exclusive, that we always only ever have to visit a city or interact with and engage community partnerships. But depending on the purpose and the intent of that test bed, I would say that it's the best practice. But I think it opens up a whole lot of opportunities too. And I think we'll see this drive the next generation of test beds, because engaging local experts and stakeholders very much is likely to enable new data access and give new insights that we don't necessarily think about as researchers. I want to tell a tale of engagement to just say that that's not easy. It's not always easy. It can be quite complicated. One of my research projects has signed NDAs with several utility companies across the state of Kansas, and we're working directly with many local non-government organizations or NGOs as well. And we had a roundtable with the group of NGOs, And when they heard me say we had an NDA with a certain company, they clamped up. It was like a chilling effect in the room because they themselves and their constituents had felt very mistreated by this company. And so it took some extra legwork from our team, from me and our team, to regain their trust. So when you work with communities, you are stepping into their reality, which doesn't benefit from, sometimes convenient academic assumptions. And so that can make things really hard. On that project, we have a full-time professional staff who's tasked with those relationships, and thankfully they've been tremendous at bridging the gap and maintaining trust across groups. And we need more of this middle layer of professionals, whether that is a professional staff on an academic project or whether that's a chief resilience officer working, in that region. But we need this for putting test beds to practical use. So to wrap up, is it possible to do all of these things for a given test bed? Not necessarily. I think some of them are conflicting. There's a big need to simplify in some cases, and then there's a big need to get as much detail as we can so we can understand where we can simplify and still have accurate or reasonable outcomes. So ultimately, the most effective and appropriate combination is going to be based off that clearly established purpose or intent set at the outset. And I think, the next steps in testbed development are going to really need to hone in on that point so that as we're driving forward on each of these items, we're staying true to that intent too. So with that, I'll say thank you so much and pass to the next speaker.
Okay, well, thanks, Elena. As I mentioned earlier, we're going to switch right to Liam, who's going to share some of the work he's been involved with, an exciting project in New Zealand. And then after Liam, we'll have some time for Q&A. And remind everybody, there is Q&A, at least I'm not seeing many questions there yet. Or if you don't have a question, if there's like a topic you'd like to hear some elaboration on, or again, if there's a point you'd like to make. So with that, though, I'll turn it over to Liam.
Great. Thanks for that, Greg. Right. Okay. So yeah, thanks for the invitation to speak today. And I'm just going to talk about some work that's been going on in New Zealand. I guess given the size of New Zealand, it's a reasonably small country in terms of population. So when we're thinking about testbed, or the way that we've attacked things is to try to look at the entire country when we start to explore some of the research in the space. So yeah, I'm just presenting on behalf of, as you'll see, a wider team of New Zealand researchers and the sort of broad collaboration approach that we've taken in New Zealand. So just to provide some context for New Zealand, and we're on the other side of the Pacific, down the bottom of the Pacific Ocean there, and we sit on the base plate boundary on the Ring of Fire, and as such, we have plenty of hazards to deal with. So this is the map of New Zealand as shown here. North and South Island country's got a population of about 5.3 million, so not significant. But as we sit on the plate boundary, we have to deal with significant levels of shaking when we're thinking about earthquakes. So this is just an example of the PGA map from the latest National Seismic Hazard Model. When we're thinking about models of representing performance of the ground, we've got plenty of areas that are susceptible to liquefaction. A lot of our towns and cities, as is the case in New Zealand and worldwide, sit in these sorts of areas. We have to deal with those problems. As we sit in the Pacific and the Ring of Fire, there's plenty of sources of tsunami, our own local ones, and then the ones from the other side of the Pacific Island that we have to deal with. So we have a large tsunami hazard along the coastline of New Zealand. This is just an example of the wave height at the coast for a 500-year return period. And as you'll see, we're trying to look less at single hazards and try to look across all the different hazards that we face when we think about decisions around resilience, risk, and how to deal with it. Particularly New Zealand is a small country with very constrained resources. We have to be more nimble in the way we think about how we improve our resilience. Okay, so that's just a bit of context. Really important in the outset, and this feeds on from Elena's presentation, is we're lucky in New Zealand that if we look to the practice and alignment of practice, and I'm going to focus on critical infrastructure in my presentation, but we could talk to similar things when we think about housing and buildings, is in the practice, we have what's called a New Zealand Lifelines Council. And that's an organization that represents all sorts of different utility companies, or critical infrastructure is sort of the term we use now in New Zealand to think about all the different utilities, roads, power, all those sorts of things that provision sort of in everyday life. But we have a New Zealand council that sits and meets regularly to discuss and plan better understanding of natural hazards, risk resilience and decision making. And then if we look to the map of New Zealand and all these different regional areas, we also have regional lifelines groups. And so at the regional level, we get collaboration across all those different critical infrastructure sectors. They meet regularly. We have researchers that are involved in those meetings too, and they discuss regional planning approaches to try to think about not just as individual organizations, but as combined organizations. They attack and approach how to improve their natural hazards resilience. So that's been going on for quite a number of years. And so what it provides is a very effective structure in the practice side from which research can link into. And just to give some examples of the work that they do at the national level with the New Zealand Lifelines Council, they have regular updating of a national vulnerability assessment looking at infrastructure resilience that runs through all the different sectors, talks to dependencies and explores the different types of hazards. And what that leads to is fairly publicly available representations of some of our key issues, pinch points of key locations that if are affected could have a flow-on effect on individual sectors and multiple sectors, and hotspots where we have the aggregation of different critical infrastructure in a particular location, such that if there was impacts there, they would affect across multiple networks. So there's a lot of sharing of information in the practice to sort of inform these sorts of issues. At a regional level or a local level, there's even work that goes on where they all get together and in collaboration with the research, look to identify. So for example, the Wellington region, which has many faults running through it, they've looked through and prioritized across all different critical infrastructure sectors, what would the best value for money projects be that would enhance resilience across the region, not just in an individual sector, but across all the different sectors. So that's a nice way for research to feed in when we have us coming from our side in the research world to link into that system. If we talk to research in New Zealand, we're a small country, not a huge number of universities in the order of 10. And what has really occurred over the last 10 or so years is really a push towards strong collaboration. Almost more than competition is, with a small number of people, competition becomes less efficient. So actually working together more as a team actually helps to, I guess, better reach towards sort of impacts and outcomes, as I'll talk about later. So we have various different large multi-year research programs, some names shown here, cutting across all sorts of different hazards, but they're multi-institutional, multidisciplinary. So I'm a civil engineer, but this cuts across from the hazard through to socioeconomic and everything in between. And even within these different programs, there's lots of encouragement from the funders to actually have collaboration across those programs. So by doing that collaboration, both through multiple institutions, but also those multiple programs, you can actually get more of the sum of what the individual programs tried to achieve to start with. This has been really important for us with building capacity. I think mentoring, developing new research applications, filling the gaps in between these different programs is really important. So we've built that really strong collaboration on the research side too. What that means is if we work to align ourselves on the research side, and there's lots of alignment on the practice side, is we have sort of an efficient way to link between the two. And one of the other key things that's motivated this is this move towards mission-led research in New Zealand. So sort of science excellence, or excellence is one end of the scale, mission-led is the other end of the scale, where the priorities are actually defined by practice or by stakeholders. So we go to the stakeholders and see what needs to be done, and then we have to frame the research projects still with excellence. We want to do excellent new things, but it's less about you're assessed less on how many papers you produce. You're assessed more on what's the real world change you're actually making as a result of this research. What this is really important is instead of having one practice organization where 1 million different people from across all different organizations are all hounding them for information, there's actually coordination first on both sides and then sort of a link between. So you're funneling through together. So there's point people, which I guess I'm sort of one of those, or events or committees where we effectively bring things together, create requests or identify or discuss opportunities. And this is sort of prevents what we call stakeholder fatigue, which was a big issue in the past where it was all fully competitive and you sort of annoy people to the point that they don't actually want to engage in research anymore. So by doing this, it's actually encouraged this research and this trusted long-term relationships within research, within practice, and between research and practice has been key to actually enable all the stuff we've been able to do. What this has done when we think about research is this sort of tagline of real world data, real world scale, and real world complexity. It changes the way you think about research when this is actually sort of the focus of the work that we're trying to do. So let's just dive into a little bit more. So New Zealand is a test bed. As I said, we're small enough that we can do that. So if I think about the test bed and some of the things that Elena was talking about, let's talk first about some of the built environment data, and we'll focus on critical infrastructure. So working with all these different stakeholders across all the different sectors, and you can see sort of the little symbols and work it out for yourself what that means. We have national scale models for pretty much all of the main critical infrastructure networks across the country. And then a bit of what Elena was talking about is some really good information on the population, of course, that links to those, because without the population, there is really no point to all the other physical things that we're looking at. So at the national scale, that allows us to explore things, and then we can focus in a very zoomed in way, depending on the application to some of the regional and local scale. So this is the Wellington region I mentioned before, and this is some focused in area on the central business district of Wellington. So if this is Three Waters power distribution data, so we have in some cases, given the trust we've developed, have data to the household for every single infrastructure in a region to tie back to the sort of national scale. So it links back to this question, because we have access to such high resolution data, some of the stuff we're exploring is, well, okay, now we can actually test what data resolution you actually need to support those different types of decision making. Now, you may not need this level of data if you're looking at a regional scale implications, but if you're focusing on a house by house, then maybe that's some of the things you might need. For example, what's the material, the laterals that link from the network itself into each of the houses? Having that information is a piece that's pretty critical to the function of a water system, but typically you don't know what those are. But when we have access to that, you start to think about, actually, are those the weakest piece of and the most important piece of the puzzle? We just didn't have access or know what they were prior to sort of any sort of work. So we have a lot of data, which makes me scratch my head a lot. It's quite exciting in a research side, but yeah, it really changes the way you think about research or how you attack. There's not much ability for optimization when you're dealing with this level of data. Elena also mentioned some of the aspects of improving different components, and I think Greg did too at the start. Is one of the key pieces we realize is we haven't done as much as we could to collect information in past events, to leverage that to improve our representation of components of different models. And the key thing for us in New Zealand is we want things applicable to New Zealand characteristics. We have a lot of vulnerability and fragility curves available internationally. The vast majority of them are very regionally applicable, but when you try to apply it across everywhere, you realize that that doesn't really represent our construction characteristics. So again, to do this and get sort of high resolution component data requires good relationships. So even back in the Christchurch earthquake, this is examples for the potable water damage and the network and the 11 kV power distribution network cables and the damaged locations. We're able to access that, which allows us to develop these sorts of models and improve. What we've realized there is that requires collaboration post-event, so working alongside the stakeholders to collect and share, and to the point of actually going back and forward in peacetime to say to the different stakeholders, hey, if you're collecting this, this, and this, it may not be immediately applicable to your immediate recovery, but that data will actually add huge value moving forward to improve these models by collecting them, because usually we lose this perishable data and it's lost forever. So lots of relationships allow us to think about how we collect things for future events. National consistency is really key when we're thinking about things at a national level, because you've usually got sort of a patchwork quilt of different information that is different in terms of resolution, character, etc. So really important, if we're going to assess things, we want to ensure that they are consistent. And that's across both the built environment data that I talked about previously, and then also different hazards. So one of the examples we can do, and we're advancing this quite a bit this year, is we have nationally consistent natural hazard data sets at multiple different return periods for all these types of hazards. It allows us then to link to different aspects of the built environment. So this is looking at every building footprint across the country, trying to explore ways to aggregate these different hazards to look at aggregated hazard exposure, and where you have things that are better or worse in terms of that level of exposure. For those of you know New Zealand, this is where the fault line runs. This isn't that there's no hazard, there's just no building footprints in the white area. But we can really explore that when we have these nationally consistent data sets across the country. National consistency, as I said, in relation to the built environment data themselves. So we have different levy systems, or stop banks as we call them in New Zealand, for all different regions. We worked to combine all those together in a consistent way to create a national levy data set. And that then means, based on that national consistent data set, we can start to make nationally consistent assessments. So for example, here, this is looking at exposure to peak ground velocity based on the seismic hazard across that nationally data set, and allows us to then make some direct comparisons about which regions are more or less, potentially more or less impacted based on that sort of hazard. Going back to the national scale, and a key piece that we've explored at this national scale is to look at not just the direct disruptions, but also the indirect. So there is a national interdependent model. So all these different infrastructure models, the dependencies between each of those networks. So if you have an outage in one network, it propagates through that network and then into other networks where there are dependencies, allows us to capture direct and indirect and understand the scale of the direct and indirect. And perhaps not surprisingly, the indirect implications are often broader than the direct when we're thinking about a particular hazard exposure. But if we look at this and do sort of a random removal, it allows us to understand how for example here, the electricity distribution disruption, so the level of disruption of the electricity distribution on these bottom axes, and how that then leads to the level of destruction of other sectors. So air travel, shipping, rail, fuel, and then the power itself. And then make comparisons between the sort of data-driven model and some expert-derived or expert-elicited model, where people who understand their networks make some estimates based on what that looks like. And interestingly, in this case, those were actually pretty well aligned, which isn't always the case. But we can use the national scale and the linkages to really explore that. As I said, we can focus down regionally. And so here's an example of network nodes. So we have these full network representations for electricity distribution, water supply, and wastewater in the city of Christchurch. And then based on that, the key piece is to link that to household counts. So as we sort of look here as an example of, I guess, the degree of resolution as you move from green back towards into the red colors, these are points or nodes within the network that influence larger and larger and larger amounts of households as you move further and further up the typology of those different networks. So we can characterize who relies on what within those networks, and then start to explore some of what's driving the impacts, both in a direct and an indirect way. So for example, here for a coastal inundation event, we have direct impacts in yellow, where those are the houses that effectively get wet. And then the indirect, all the properties that may not be inundated, but other parts of these infrastructure systems were affected. And you can start to see what types of infrastructure systems are affecting or are going to influence these different households. What helps to identify or align, I guess, decision makings about changes that might be made to look to both the, I guess, influence of the direct impacts, but then how we change the networks to reduce some of those indirects. And there's different approaches we then need to make about our decision making. Systems, and particularly critical infrastructure systems, are dynamic. So a lot of the work we're trying to explore is to represent these, not just the physical location and the characteristics of those, as I've talked about previously, but also the dynamics of the systems too. So a really interesting example was if we had an alpine fault earthquake on the South Island of New Zealand, this is sort of a representation of the intensity of shaking, and this is all the different infrastructure systems. If we looked at the electricity distribution system on the west coast of the South Island, an alpine fault earthquake would damage the transmission system, meaning that this area would no longer get access to power through that transmission system. So this work was a sort of back and forth collaboration with the electricity distribution company in that area to look at linking damage modeling to electrical analysis, so modeling of that distribution network, and then working our way through how we would use the embedded generation in that region to run that network as what they call an islanded mode, where it's no longer connected to the transmission network. So some quite detailed electricity network analysis to try to understand how to start it, run it, make sure it's stable and it runs in a functional way. So you've got sort of a different approach to run that network when it's isolated from its typical source through the transmission network. Similarly, we can look at road systems, and we used research and natural hazards research to build transport models for the entire country in business as usual time, and then we used that to assess and explore disruptions to those transport systems, both the state highways and all the local roads in between, which are really important when we're thinking about the redundancy of that. If you just looked at the state highways, you miss some of the redundancy that the local roads can provide. But if we look at disrupting different percentages of this network, I'm just using sort of a random removal example here. As you disrupt higher and higher percentage of the network, the number of cancelled trips increases as that increases. And then the other trips that can still occur, we can start to look at the increasing in travel costs due to travel times for different types of network users of the network, commuters, tourism, and freight. And then also add other aspects of cost to that too. For example, the emissions costs. And we're also looking at maintenance and other aspects of costs when we have to shift traffic to different parts of the network. And this is now also being used across about 500 different earthquake scenarios to understand what those implications are on that broader context. So you can really delve in quite a lot of detail when you have some of these dynamic representations of these systems. So to summarize, I guess the key lesson from our side is there's a lot of hard work and a lot of time and a lot of development of relationships to get to the point where we are now. So the strong culture of collaboration within research, within practice, and between research and practice has been based on that work. So that means that we really scope most of our projects and research based on this real world data. And we have over 10 universities and research organizations, easily over 50 different practice partners. And over those 10 years, we've had tens and hundreds of researchers and practice partners working together in this space. This term, I think, which Elena was describing earlier, co-creation is really a term we use in New Zealand, where this is this mission-led, mission-driven approach to research, where we work alongside the stakeholders at the outset to co-create the research projects and the programs. It's interesting then with that balance of excellence and impact, but we're moving a lot more towards the impact, and usually the funders want both for the same cost, which is okay. We've worked out how to do it, and I think just because of the access to that real world data, that often underpins the novelty of the work that we were able to do. As I said, there's a wide range of research ongoing on all those different pieces, and there's plenty of work still to do to up all the different components as presented by Greg at the start, and we'll always ever be evolving that, but we've got a good baseline to continue to build. And then again, like you did the previous presentation, always an issue, and this is both in research and in practice, and things like emergency management, is the maintenance, cleaning, and updating still remains a challenge, and that longevity of data and supporting systems is difficult in a research context. So we're doing a lot of work with industry to sort of show that that's really hopefully where that will sit for that long-term use in both research and practice. So that's it for me. Thanks very much.
Okay, well, thanks, Dan. I mean, that's a tremendous accomplishment for you, for all the folks that were involved in that in New Zealand. It's yeah, pretty amazing. We do have a couple of questions here, so that were put in, and again, if actually we have 3, it looks like now. So if others have them, but let me start with a question that Henry Burton had posed, and he posed this to Elena, but maybe Leon might have comments as well. And his question is, what are some of the testbed architectures that you have encountered in the literature, and is there a role for artificial intelligence in the design and the development of future architectures? And I guess you might clarify first, Elena, the word testbed architectures. Henry points out it was in one of your papers, but I assume that's kind of like how just the whole thing is organized. But
Yeah, thanks. And I just agree, everyone chime in. I'll have to go back and look in the paper to see exactly how we use that language, but that's how I would define it, Greg, right? Is how, if we're bringing in different data sets, how is everything coming together kind of, and the design of those workflows and whatnot, to have, I say, a test bed. And, I'll say in the review paper, I don't think we got into this very much, because again, like I said, when I was presenting so many of the papers, it was like background. It was just like this thing was there that we used, and no one really talked about what that thing was or how they got it. That was, and it could be that, we missed some of the papers, but just to say that was so often how many of the earlier papers were, circa 2021, 2022, 2023, more modern times, with NCORE, with the SimCenter, other groups, we're starting to see that be more directly articulated in papers. But I would say from looking at, and a lot of the test beds, like the Clark system is one you can go and download and use on your own, so you can infer what the architecture is, for example. But a lot of them were not necessarily accessible for our team to get our hands on and to see what that architecture was, so how things were put together. But I'll say, in a lot of ways, from my experience being on the NIST Center of Excellence, the NCORE team, in some ways the architecture was the same on that project. We were using Jupyter notebooks to bring things together, PyNCORE, but in a lot of ways, and what I imagine to be true across the board, is they were all actually quite different too, because depending on which data sets were being used, for example, what type of format they were in, what quality controls, what details were critical for what was being assessed in the testbed itself, all of that changed then, how they were used, how they were brought together, and so forth. So even in our testbed development paper, we have a sort of a methodology for developing testbeds, but it's at a very high level because all of those details are going to matter. So set what that preliminary purpose is, bring data together, verify, validate that it's working, but it's not, prescribing, do exactly this, do exactly that, because again, what your purpose is, what kind of data sets you're bringing together, what tools you may have access for, and how those tools are just continuing to evolve over time, all changes. Henry's comment also asked about the role of, say, artificial intelligence. And I mean, I think that that's huge. And that's a thing that has just progressed tremendously just since that work was done, and how much, you know, researchers, individuals can develop that, but also have access to different things. And so, you know, the SimCenter, I think y'all have different tools, the BRAILS system, you know, there's a lot of that already being used in testbed development now. And I think there's a lot of opportunities when we talk, when I mention things like reverse engineering to de-identify data and make it truly anonymous. I think artificial intelligence has a huge role there, and filling in gaps with some, so even kind of building on the second question that came in a little bit, but we can talk more about that question specifically in a minute. You know, using artificial intelligence, for example, and even, you know, to fill in gaps with data, but even using large language models to see if we can replace survey responses to hard to reach populations. So I think there's a lot of ways that it can be brought in, and we'll just increasingly see that happen.
Yeah, and Leon, before we move on to another question, do you have any comments on this question of architecture? Like we described, Leon, developing over 10 years. Was there an architecture at the outset, or did it evolve with each new stakeholder you brought on? Or
Yeah, I think a lot of what we've been trying to drive is the push for that to be done on the practice side. So when we're thinking about that sort of data, is to make it so it is then going to be fit for purpose, and it's not going to stop at the end of the funding cycle for a project. You may lose everything. So a lot of the drive is how we're improving the representation of things on the stakeholder side, because they will be updating and improving that. So it's different when you have that ability to do it, because I think we've shown in events, you know, very recent big storm events, is the issues that we see every time we have an event of lack of situational awareness. So the data to inform situational awareness is the same, very similar, if not the same, to the data that would underpin this sorts of work. So it's this taking a multi-use view of how this is done and shared in a way that it ticks the box for all those different sort of things, both the research side and the practice side.
yeah, I think that the whole notion of a testbed, I think, is one that could spawn different uses that even the first people who did a study didn't even think about, but that the data is put together and other people could pick up on it and do that. Yeah, that's a great point. So I guess if we move on, Christianos asked a question about, you know, if you think of some of the most at-risk areas, these are high risk, but they're data scarce. You could think of places in Lima, Nepal, Manila. Just some thoughts about what could be done in order to create test beds for those regions. You know, and the tricky part, thinking of Liam's work, is who would be the stakeholders maybe there, who would be, you know, utilities or government agencies or others who would help with that.
Yeah, I could start.
Okay.
That's actually one of the motivators of this testing of different resolutions is exactly that.
Mm-hmm.
We have a data-rich situation. You can understand what is the minimum amount of data you need to identify the key things that are going to trigger these issues. And then by doing that, you can translate this to these areas where perhaps you never are going to be able to collect the data, but what is enough to capture those key aspects. I know we have colleagues here that, you know, do stuff simulating the modeling of power networks using like satellite light, night satellite imagery can be used to simulate the representation of where the power networks are. And so you've got that one way to do it, and then the other side, you can say, okay, well, this is the amount we need to represent this topology in such a way that you can start to make useful decisions. So I think that's really the key piece, because we don't really know, and so that testing initially will help to then translate to these other regions, we hope, and that's sort of another parallel piece of work that's ongoing.
Okay, so like knowing how much resolution is needed. Okay. And Elena, do you have any other additional thoughts on that?
Yeah, I mean, it's a question that I think we could spend a lot of time discussing, because I really like everything that Liam was just saying. It's really complicated too. I mean, some of the examples I listed when I was presenting were indigenous peoples. So here, how do we go and we collect this data when there is a big kind of, national conversation, a big movement in a lot of ways for data sovereignty for Native people, right? And so, do they want us to be modeling them? And that's not just true for indigenous peoples, that's true for everybody. And as we go and we get this, additional level of granularity, yeah, at what points are we impeding privacy? And so just to say, I do think it can be really complicated when we're looking at really high risk areas where people, in the United States, at least, which I realize are not the locations listed in the question. But when we're looking at the United States, these areas with more vulnerable populations tend to have the least trust in researchers and government, for example. And so then if we want to, so how do we, convince them this is safe for us to do? How do, so it's really complicated. When we were doing the Lumberton field study, one of the housing units that I was with, and it's funny because I was with an employee from NIST who was really involved in the Twin Towers collapse investigation. And so when we walk up and we're trying to do a survey with this household, the guy, nothing on us was it said, Center of Excellence or Community Resilience Planning, but just immediately jumped into like, he doesn't have any cell phones. He doesn't have, he wants to be off the radar, and immediately even started talking about conspiracy theories related to that specific event. And so just to say that, I think it has to go hand in hand with data sovereignty when we're also thinking about how we can address the needs of more vulnerable populations. But then areas that are a lot more remote to get to. One of the places in my slides, I actually had an image of a village in Western Nepal. And that was one of the visualizations on my slides. And so we had to, take 2 local flights and then hike a day and a half to be able to get to that village to document where the details were. Google Earth has come a long way since then, so you can kind of see a little bit more of it now. But without being there in person, I wouldn't have known. Like, there's a lot of things I still can't tell from Google Earth that I know because I went there in person. And so I do think there's something to say about still visiting places that we want to model and still trying to create the relationships with the people who are there, instead of kind of doing it without them necessarily being involved. But anyways, I think it's messy and complicated, but it's an important topic to continue talking about.
Yeah. I should point out too, I noticed on our participants today, one of our participants, Janice Rogers, works with the nonprofit Geohazards International, which of course does work on the ground on these sort of problems or issues. So getting that local connection is key. Yeah.
Absolutely. Great point.
So maybe if we switch to a couple more questions, and then we'll need to switch to Adam's talk, but Jose asked a question, and of course, on uncertainty, quantifying and propagating uncertainty, one of our favorite topics. And in particular, he's pointing out, I think a good question is to, there's been a lot of work on, say, characterizing the uncertainties and the hazard and spatial correlations on, say, ground shaking. But he's asking about the uncertainties in the building inventory or bridge inventory and network. How is that collected, propagated? I don't know, Liam, how much that was done in the New Zealand work, and if so, how much did that uncertainty affect the final answers? That gets to the question of resolution a little bit, but in this case, it's the resolution of uncertainty.
Yeah, I think significant maybe is the right word, and I feel, I think I mentioned in my talk, I think the vulnerability and fragility models, we've advanced our hazard models significantly, but when we link that to the so what, the uncertainty blows out. And if you're looking at regional level losses, then maybe that evens itself out. But as you focus on further and further, that increases. I think the way that we've said, yeah, I guess the way that I've looked at it is the key piece or the key aspect of this modeling is comparing two different realities, right? The uncertainties will always be there. And I think we've got a long way to go before we reduce them down significantly. But if we are modeling in a consistent way, looking at existing representation of the built environment and then the implementation of different interventions, it's the difference between those two realities which is the most revealing. So we accept that those uncertainties are going to be there, but it's those shifts and those differences, that's where we really see that we can help to inform decision making. It's harder when you're trying to prioritize, but I think the prioritization plus the testing together then helps you to sort of identify what those decisions might be. But yeah, there's plenty of uncertainties, and I think you could probably do tens and tens of years of research on improving vulnerability and fragility models and still have tens and tens of years to go to keep on developing them to capture them further, which is great for us as a research community. But yeah, when it comes to making changes, it's the differences I think is key, particularly when we're working with different stakeholders.
Yeah, how it's impacting the problem you're trying to address or the intervention you're trying to assess. Yeah. And let's see, there's a couple of related questions. Actually, Elena, this is one that you had asked to Liam. And also, I think it's related to Tim Tsai's question about, well, maybe to what extent all of the effort in New Zealand was received by the stakeholders. You know, if they were assessing interventions, and it feeds off the last question on the uncertainties, right? Did you see the stakeholders, utilities, you mentioned other agencies, were they really benefiting from the quantification or the change in or the quantification of the change in risk? It seems, my sense is a lot of the benefit is just from putting all the information together. Folks realize they might have a problem, but then how big that problem is and how beneficial an intervention is kind of a key question. So, yeah,
and I think a lot of this is it's much more effective if the stakeholders are part of this co-created project from day one, because they also guide the research. You know, we can sometimes be going into a little bit too far into the academic side, and they'll grab us and shift us and say, you can still do cool stuff and impactful stuff, but let's go in this direction. So yeah, we've been able to inform in many different ways through the testing with communities, exploring for different community interventions, and that's sort of all of infrastructure level. And even to the point, which I quite like this approach, and this is something we've been trying to do in the last few years, is providing the data and then helping to train or develop internal capability within these critical infrastructure organizations themselves. So they're seeing the value of having GIS and data scientists as employees, that they can see what we're doing and learning, and then they implement it within their own systems, and then they're able to test. And that's one of the coolest things I've seen really recently, is you're helping to almost develop a work program for an employee of this company to say, this is the cool things you can do, and we can talk back and forth. So it's at a lot of different levels, like painting the picture through to developing capability, and then sort of everything in between. And it's not a one size fits all, right? It just depends on perceptions of these different organizations and what they want to achieve.
Yeah, I think, for academic researchers, that's probably a key point. Like, we could run a simulation and give a utility an answer, but whether they believe it and embrace it would be different than if we give them the tool, they run it, and then they kind of have that joint ownership of the simulation. Yeah, it's a great point.
Greg, can I ask a really quick follow-up on that? Liam, I'm wondering if your research group, have you all been able to integrate like communications experts or psychologists or behavioral economics or behavioral scientists to kind of like test that out a little bit of using their science to say, if we present the information this way, it's perceived that way, or kind of what does help facilitate that a little bit more? Have you been able to do any of that?
Yeah. I think, where the civil engineering expertise stops to notice a stop, risk communication is massive, right? And how to present the data. And there's lots of work in that space, particularly if we are framing, building through scenarios from hazard through to characterizing a scenario. And then the next piece is, as you've described in your question, whether it be an infrastructure organization or to a community, the way that you have to frame things is very, very different, right? Because of the underpinning perceptions or understanding of how you digest that information is really critical. So I'm certainly not an expert in that space, but there's a lot of work making use of sort of through the hazard to the built environment to capture or paint the picture. And that's why I think scenarios is super important in that process, because it sort of frames something that people can digest if you represent it in the right way. So yeah, there's a lot of work in that space because of how critical that is to informing decisions at all those different levels.
Okay, well, I'm enjoying this discussion, but I do want to suggest maybe we'll move on, as I'm looking at the clock, and invite Adam to present a little bit what the SimCenter is doing, and we'll see how, unfortunately, that might run us close to our time together today, but let's get started with that. But I'd like to, again, thank Elena and Liam. I'm really glad, Liam, I got the suggestion to invite you to participate, because the effort you guys have done in New Zealand and the engagement is really a great model. So Adam, why don't you take the screen?
Thank you, Greg. Just a second. All right, I hope it works.
Yep, we can see it.
Yeah. Okay, all right. So I will spend the next couple of minutes to provide an overview of what we are planning to do with our test beds in the near future and what our vision is in general going further into the future. We have been working with test beds at the SimCenter for a number of years now, but recently we started to review and revise them. And part of this revision is not only trying to bring new data to these test beds, but we are trying to be more mindful and articulate what the objective of test beds should be. And I think there was a lot of great discussion today about that. I have a part of Elena's slides here in the corner showing that researchers do have an opinion, and we want to listen to that opinion and not only care about the data and the models that are involved in our test bed, but we believe that as the SimCenter, we have an opportunity here to also think about the infrastructure for the test bed. So how is the data organized, and how can we contribute to that to make these test beds more used and more useful? And I would like to walk through a couple of objectives that we identified through our review of the literature and conversations with folks like Elena and Liam, because these are the things that will drive what we are doing in the next phase. And we invite everyone on the call and even more broadly to provide us feedback and comments on these if they think we missed something or if they just have some suggestions on how to do these things better. So When it comes to these core objectives, the first thing is to have reproducible simulations. There's a lot of talking about how important that is in our field, and testbeds would really push everybody towards that by introducing standardized ways of storing data and then controlling the version of data and models that were used in a particular simulation. It would just make it easier for anyone who was not part of the original group who does the simulation to pick it up and then run it again. Now, beyond running simulations again, it would be great if the data could be used for other things. So something that the original group didn't even intend or think about could come out from another context, from another group that picks up the data. In order to support that, we have to make sure that the data schema that we create are flexible enough to be extensible, to be used in a slightly different interface with a slightly different tool. So we don't want these test beds that are created to be exclusive to a particular simulation platform or a particular simulation workflow. We imagine them more as a collection of data and models that are as flexible and open as possible so that people can really experiment with them. Another step here, or another objective, is to make sure that this is not exclusive to a particular group. I think this is quite obvious. We want this to be a community building opportunity. So we want to welcome everyone to contribute, but it's not enough to just say that everyone should contribute. We want to be very particular about providing guidance and information on how to contribute, what kind of responsibilities contributors have, and what kind of benefits you can get if you contribute to a test bed. I think this can engage more people and could lead to a more diverse and active contribution in our community. And one of the things that the contributor really gets is credit, right? So if you contribute to a test bed, people will recognize your work and you are able to influence what others are doing in that area. So data provenance that keeps track of where the data came from into the testbed, who made it, and under what limitations that apply, is very important. And we believe that a distributed ownership is a better model. So rather than say the SimCenter having a testbed and collecting all the data and managing everything, we believe that everybody who contributes should have control over the data that they contribute, should be able to update it, should be able to modify it as their work progresses or as they make new collections or new changes to the data. And of course, the DOI for every contribution will help people being able to claim that credit that is important. While we want everyone to contribute, we want to provide some minimum requirements so that if a user, not a contributor, sees the testbed and wants to use some data, they should be sure that the data works with the kind of tools that are supported by the testbed. They should be sure that it has the required metadata so that they can understand what is in the data, what are the limitations that apply, and so on. So that kind of quality assurance is important. And another thing for the users of the testbed is to make it easier to discover the data. It's not enough to just have a repository where everybody throws in a folder and then we have a lot of folders and nobody really knows what's in there. It would need to be a little more deliberate and a little more organized than that. But we believe that AI has a role here. Maybe this is referring to what Henry Burton asked earlier. I think AI-assisted search among the data as these testbeds grow large could be very powerful in helping people to discover what data they can use for a particular research. And of course, this is also taking some of the work off the shoulders of the contributors because they don't have to worry so much about labeling and keywords and all of those things if we have a structured representation of the data that can be searched effectively with AI. And finally, this is also something that came up a couple of times over the last hour, translation and engagement. So it's important, or there is an opportunity at least in these test beds to collect ideas from the community and focus on intellectual merit as well as broader impacts. So you have a location, we have a lot of data there, and we could collectively see what are the opportunities there that we can make an impact in that location with these data. And then if everybody is working towards those, then we will probably accelerate how much and how quickly we can do. So with these objectives in mind, we started to think about how to implement our first test beds that are really prototypes of these prototypes that would deliver on these objectives. And there are a couple of practical challenges we see and opportunities we would like to seize. And the first 3 bullet points are fairly trivial challenges. I would like to focus on the last 2 now. So I think it would be important to support private data. This also came up earlier today. It would be great if someone, either a utility or a researcher who has a student and they want to protect their data for some time, would be able to share it within the testbed so everybody knows that it's there, but it's not public yet. Still, knowing that it's there would avoid people doing redundant work, and people could see that there's an embargo period, and after that they can start counting on that data and building on it. So it makes it much more efficient to work collaboratively and to see what is coming out of the community in the near future. The other topic is this maintenance, where we have the contributors, but there's an umbrella organization or a group that maintains the testbed, that looks at what is coming in, makes sure that the quality is there and all of those things. And we believe that it shouldn't be just SimCenter or whatever other group. This should be a testbed specific group that is regularly updated and is comprised of folks who care about the testbed, who really think about how to improve it and who have a stake in there. So ideally, this would be open and people could join if they are so inclined. So considering these challenges, we looked at a couple of options of repositories. How could we store all the data that comes in, all the data and models that come into a testbed? And we believe that among these, Design Safe, which is another NERI project, is a very compelling choice because of how state-of-the-art their cyber infrastructure is through the Texas Advanced Computing Center. They are already collaborating with SimCenter, so we could do some custom developments that are needed for this testbed, and they can provide a free repository through NSF support for even large data sets that are often part of these testbeds. So we are looking at Design Safe, and we are exploring how we could collaborate with them to bring these testbeds to life. Now, when it comes to the actual testbed that we want to seed these infrastructure with, we have 3 locations now. One of them is an earthquake testbed. That's the San Francisco Bay Area one. And what we want to do is look at what we've done there in the Bay Area in the last 9 years, collect the data and seed an initial repository with it, but then immediately invite researchers and others in the community to contribute to that and work with us on developing these best practices and developing how to manage this data well. We hope that such work pretty rapidly will help us deploy new testbeds when there's a new event, for example, and we would like to support reconnaissance efforts by collecting data and allowing community members to access it quickly in an organized fashion. And of course, in the longer run, it would support the kind of benchmarking and collaboration with broader impacts that I mentioned earlier. So when it comes to the San Francisco Bay Area testbed, here is a list of data that we see that we believe would be helpful for research in this area. And of course, all of these data come with appropriate metadata to help you understand the context it was created in and the limitations that come with it. You can see that there's inventory data, including national data sets, and our BRAILS++ tool can help create inventories of buildings, transportation, and power networks for the area using that data. But there's also very valuable local data in the Bay Area because a lot of cities collect such data and make it available online. We have intensity measure fields from various different modeling approaches for earthquakes. And this is an earthquake roundtable, so I'm not going to talk a lot about other hazards, but the Bay Area is not exclusively under earthquake risk. There is wildfires, there is floods. So there are other hazards that could be included in this testbed. We have locally appropriate models of buildings, infrastructure, and the local geology that helps make those studies more specific to the Bay Area and more useful for the local stakeholders if they want to see the outcomes. There are a lot of reports. There's a few earthquakes, fortunately only a few in recent decades in the area, that can help validate or ground truth some of the research results. And of course, these testbeds are not just data repositories. Models and simulations are an important part. So we imagine that researchers and SimCenter also would share the scripts, the inputs and the outputs for those simulations so that others can reproduce and build on top of them. And just an example of what is possible, we have recently, just last 2 weeks, ran high-resolution simulations for the 2 million buildings in the Bay Area. And these simulations today take only about 6 hours on a high-performance computing cluster in DesignSafe and include 2 million nonlinear dynamic analysis, including uncertainty quantification. So you can do a lot in a relatively short time. And really the challenge today is to make these high-resolution simulations also high fidelity. So testbeds could help us go in that direction. And to close my thoughts, I just want to mention what we have done already in the Bay Area. We have been working with the city of Alameda. This is in a smaller island in the Bay Area, about 70,000 people. And we call it a serendipitous testbed. It was not designed to be a testbed, but it happened to be a location where we collected data. And because the data was available, we started bringing our focus there when we had something to test, something to model, something to benchmark. We ended up working with the local stakeholders to influence their local hazard mitigation plan. So there was a lot of things that overlapped in Alameda. And in hindsight, if we planned this to become a testbed, now we would have a nicely organized repository and others could join easily. But since we didn't, the data is kind of scattered. It's difficult to share. So we have experienced that working together in a location is helpful, but we also have experienced that it would be good to organize this data well and to share it in a more mindful way. And that's basically where we are going with our San Francisco testbed in the 2.0 version. And with that, I think we have another minute to discussion.
Okay, but yeah, thanks, Adam. And point out, Adam, his role in the SimCenter as Associate Director for Research Outreach and working together with Frank McKenna and the rest of our team is really given a lot of careful thought, I think, as Adam just described, to really looking at what's been done in testbeds, the SimCenter and other folks, and really to articulate the issues. And as we call it 2.0, if we were to redo them again, or at least to launch new testbeds to learn from what we've done in the past. And I imagine, Liam, after the 10 years in New Zealand, that if you were doing the 2.0, there were things you would do differently. You know, you've learned from those experiences and things. And so, at least in the SimCenter, we're trying to kind of harvest that information. It's building it into tools, but it's also building it with the community members and things like that. And so to be continued a little bit. So let's see, I wanted to just wrap up today. Unfortunately, we don't have time for discussion, but I would point out that at least with the SimCenter, you could go to our webpage and reach out. And in particular, if you have specific questions on the test beds and what we're doing, I mean, Adam would be the first point of contact for that. And if I could find my slide here, oops, I found my slide, but then if I could get to my controls, pardon me. Let's see. I'm going to share my screen or attempt to, and just end with a couple of slides. There we go. And it's amazing how Let's see. Okay, let me just go back. Okay, so I just wanted to, again, kind of end with a kind of pitch for the SimCenter about how to be involved. I mean, the best thing, just go to our webpage and you'll see a number. You could download tools, but you could also see some links there on how to join the community. We have these community roundtables, which are organized by working groups. This is the earthquake working group. You're welcome to reach out to me on earthquakes or to the other community or the other working group leaders. But we also have GitHub discussion pages on our different tools and things like that. If you're not already subscribed, subscribe to our newsletter. And just wanted to mention, there's a couple of upcoming events. We've had a series of roundtables, and by the way, like for today's roundtable, we've recorded it and we'll be posting it onto the SimCenter. So you could look back, and in earthquakes, for example, we had one last fall where we looked at surrogate modeling, and there's other topics there. But there's one more roundtable in this current round that's been scheduled. That's actually for tomorrow, looking at power infrastructure. So if you're interested in that, you could get signed up. Couple of workshops coming up ahead. The group that's focusing on wind engineering and CFD is having a workshop describing and giving hands-on with some of our tools at the upcoming wind engineering conference in St. Louis. There's a couple of programming boot camps this summer. They've been popular with students and a few young faculty on kind of diving into the details on the tools on Python, C++ coding, and so forth. Again, information on our website. And then finally, for folks out there who are kind of researchers and their faculty, we kind of are having another sort of workshop or get together with folks who are using or beginning to use the SimCenter tools and design safe tools, getting together in Austin, Texas in July. So those are just a few of the activities we have, but the key thing is, contacting, seeing what's available on our webpage and following up with us. With that, I think I'd like to, again, thank all of our speakers who are here, put together some great presentations, and also thank you in the audience who've been listening in and contributing questions. And this is to be continued for sure. Okay, take care. Okay.